It's visible now.
Yes, ma'am.
So I'm considering a two commodity world X and Y, and I'm considering a usual indifference curve, that is a continuous locus which is coming from northwest towards the southeast. So this is the indifference curve I'm considering. And last day we found that along the curve, as we move from A to B, that we can do, only sacrificing some amount of Y. Consumption of Y is falling. To increase consumption of X, we need to sacrifice some amount of Y. Okay. Or along the curve, as we are moving from A to B, the consumption of X is increasing only at the cost of loss of some amount of Y. Okay, this is one point. The second point is, as we continuously substitute Y by X, the amount of X we need to meet up the same loss in Y, that will increase. Which means if I want to keep the loss of Y by same amount, here also I'm losing some amount of Y as consumption of X is increasing, number one. However, if I compare the 2 points, or if I consider the movement from A to B and then B to C, what is happening? I'm losing same amount of Y between A, B, and C while I'm moving from A to B and then moving from B to C. However, to compensate the loss in Y, I need more of X. In other words, as along the curve, I'm moving from left to right to meet the same amount of sacrifice in Y, I need more and more of X. Okay, the first idea, that is when I am changing Y, that will result in change in X. That will give us the notion of MRS, and we can show this MRS is nothing but negative of slope of the indifference curve. On the other hand, the second point, that as we are continuously moving from A to B to C and losing same amounts of Y, we need more and more of X to compensate the loss. That is known as diminishing
Marginally.
MRS, not marginal utility. Okay. Last day, if you have noted it as MU, so please change it. Diminishing MRS, diminishing marginal rate of substitution, diminishing marginal rate of substitution. Diminishing marginal rate of substitution means the slope or absolute slope of IC becomes flatter as we move along the IC from left to right. Diminishing MRS, diminishing marginal rate of substitution, that in turn indicates absolute slope of the IC becomes flatter as we move along the IC from left to right. And this in turn indicates convexity of the because only for a convex curve, as we move, if it is a convex curve, as we move along the curve from left to right, the slope becomes flatter and flatter. So only for a convex curve, in other words, a strict convex curve, it is possible that the slope will become flatter and flatter as we move along the curve. So the entire concept is interrelated. So first we are putting a negatively sloped continuous locus that we are calling indifference curve. Then we are finding that along the curve, if I move from left to right, I have to off one commodity if I want to increase the other commodity. This, as we are leaving some unit of y, what amount of x we need to compensate the loss and staying on the same indifference curve, that is giving the idea of MRS, marginal rate of substitution. Okay, that is to remain on the same indifference curve. If I reduce consumption of one commodity by this amount, what amount of the other commodity will be able to keep me on the same indifference curve, and thereby the two bundles A and B will be indifferent to me. Okay, I'm indifferent between A and B because both the points are lying on the same indifference curve. However, there is a difference between A and B. At A, we consumed more of Y and less of X, whereas at B, I'm consuming less of Y and more of X compared to A. However, still I am on the same indifference curve. So this substitution, which we are calling marginal rate of substitution, is measuring how much X I need to keep myself on the same indifference curve if I reduce the consumption of Y a bit. In the similar fashion, when I am moving from B to C, I am following this similar kind of principle. I am increasing consumption of X and I am losing some amount of Y. Okay, so the amount of X which is compensating my loss of Y and keeping me on the same indifference curve is called the marginal rate of substitution. So this is first point. The second point is this MRS is diminishing. Marginal rate of substitution is diminishing, which means for the same amount of loss in Y, we need more and more amount of X to keep me on the same indifference curve. In other words, as I am continuously substituting one commodity by other, the amount I need to consume the commodity X, that will continuously increase. So this is the idea of diminishing MRS. Now, if I say MRS is the slope or the absolute slope of the indifference curve, that is minus dy by dx, which is absolute slope of the indifference curve, then absolute slope of IC becomes flatter and flatter as we move along the IC from left to right. So this is the second point. So I'm thinking about a curve for which the slope is becoming flatter and flatter as I'm moving from left to right. This is possible only for a strict convex curve. So the idea of diminishing marginal rate of substitution is telling me we are thinking about an indifference curve which is curvature wise a strictly convex curve. So we should be very clear about these 2 points. Now here I have to clarify, this part because some student asked me to repeat this part, So, before moving further, just this thing, I'll cover once again how I'm getting this. So this I can consider as a note because already we did this thing in the last class. Okay, I want to show MRS is equal to minus dy by dx, or I want to talk about the slope of the indifference curve, how we get the slope of the indifference curve. Now, to derive the slope of the indifference curve, we have to start with the utility function, which is u of xy. I'm talking about a two commodity world. So my utility is a function of two commodities, x and y. So my utility function is u as a function of xy. Now, if along a line, the utility remains constant for different combinations of x and y, we call the curve the indifference curve. I'm considering different combinations of x and y. So if you look at the diagram, while I'm considering A, B, and C, I'm basically considering different amounts of two commodities x and y. Still, I am on the same indifference curve, which means I am getting the similar utility between A and B and C. My utility level remains fixed along a particular indifference curve. So, while I am writing the equation to the indifference curve, I have to write the equation as u of xy is equal to c. So, u of xy is the utility function. Okay. So, my starting point is u as a function of xy. This is the utility function. And then when I am considering this kind of equation, that is utility remains constant for different combinations of x and y, this is the equation to the indifference curve. Now, totally differentiating above equation, we are getting del u by del x into dx plus del u by del y into dy is equal to dc. Totally differentiating the above equation, that is totally differentiating the indifference curve equation, we get del u by del x into dx plus del u by del y into dy is equal to dc. Now, c is any arbitrary positive constant, and along an IC it remains constant. So dc will be equal to 0. dc will be equal to 0. So what we are getting, del, this we can call also mu x or sorry, is it now clear?
Yes, ma'am.
Yes, ma'am.
This is also called MRS, marginal rate of substitution. So in this way, we get minus dy by dx is equal to del u by del x by del u by del y, or mu x by mu y is equal to MRS. Okay, so in this way, we get this. So derivation of the slope of the indifference curve is now, I think, fine to all of you. How we
Yes,
are
ma'am.
getting this is equal to minus dy by dx.
Yes,
So let's
ma'am.
discuss a numerical exercise.
Yes, ma'am.
Please write down an equation. Okay. So please write down. Consider the indifference curve. Consider the indifference curve given by x y square is equal to c. Consider an indifference curve given by x into y square is equal to c. That is, my utility function is x into y square. Consider an indifference curve is given by x, y square is equal to c. Derive the slope of the indifference curve. Or the question can be derive the marginal rate of substitution. Derive MRS XY, MRS subscript XY, marginal rate of substitution between X and Y. Derive marginal rate of substitution between X and Y. So everybody could write the equation XY square is equal to C.
Yes, ma'am.
Okay, then totally differentiating the equation, we get so what will be the value of del u del x into dx? What will be the value of del u del x?
Then y square.
Y square. Everybody is understanding? Del u by del x will be y square only. Y square dx plus, next what will be the value?
2xy dx.
2x. Very good, because I have y square. If I take the derivative with respect to y square, we are getting 2y and x is already there. 2xy dy is equal to dc. So we are getting this y square dx plus 2xy dy is equal to dc. And from there, if we solve the equation, we are getting dy by dx is equal to minus y by 2x. So MRS is equal to minus dy by dx is equal to y by 2x. If anyone has any problem, please tell me. Are you understanding how I am deriving MRS given an indifference curve or given an utility function also? We will be able to do this. In that case, utility function is given by u is equal to x y square. Then I'll write the equation to the indifference curve as x y square is equal to a constant. And then I'll take total derivative and we'll get minus dy by dx, and that minus dy by dx will be equal to MRS, marginal rate of substitution. Alternatively, I can write this formula of MRS. In the right hand side, please check. MRS is equal to marginal utility of x divided by marginal utility of y. Now the utility function is given by u is equal to xy square. The utility function is given by u is equal to xy square. This is the utility function. U is equal to xy square. So from there, I'll be able to derive marginal utility of x, which is du by dx. So if I consider du by dx, I'm getting y square. If I consider mu-y, marginal utility of y, that is du by dy, so I'm getting it is 2xy. MRS is equal to mu-x by mu-y, so it will be y square by 2xy is equal to y by 2x. So directly from the utility function, deriving MUX and MUY, I can derive MRS. Or alternatively, I can consider the indifference curve, which I can write from the, directly from the utility function. And then I can go for total differentiation, totally differentiating both the sides. I'm getting this equation, then solving the equation, getting minus dy by dx, and MRS is equal to minus dy by dx, which is equal to y by 2x. Anybody has any query, any question? Is it clear? Yes or no?
Yes.
Yes, ma'am.
Ma'am.
Yes, ma'am.
Everybody could complete this?
Yes,
Yes.
ma'am.
Yes, ma'am.
Very good. Okay, so now I'll give you a note. Please write down this. Um, I covered up to, I think, axiom 6. Am I right? Just let me check how many axioms I covered. The last axiom was axiom 6.
Yes, ma'am.
This was, axiom 6. So please write down axiom 7. Please write down axiom 7. And please write down within bracket smooth indifference curves. Smooth indifference curves. Axiom 7 is about smooth indifference curve. At all points along the indifference curve, at all points along the indifference curve, the marginal rate of substitution, the MRS, the marginal rate of substitution between any pair of commodities, is uniquely determined, At all points along the indifference curve, the marginal rate of substitution between any pair of commodities is uniquely determined. So look at the graph, So the slope of the indifference curve at A is uniquely determined compared to the slope of the indifference curve at B, or the slope of the indifference curve at C, or any other point along the indifference curve. So for each and every point, the slope will be uniquely determined. All the slope values are different. So slopes are uniquely determined for every combination of two commodities along the indifference curve. So this is called the smooth indifference curve axiom. Then add the implications of axioms 5, 6, and 7. The implications of axioms 5, 6, and 7 taken together can be summarized as follows. Next, proposition 1. for any pair of commodities, for any pair of commodities, xi and xj, for any pair of commodities xi and xj, given the quantities of all other commodities, for any pair of commodities xi and xj, comma, given the quantities of all other commodities, comma, the marginal rate of substitution of xj for xi the marginal rate of substitution of xj for xi is a continuous and strictly decreasing function of xi. Continuous and strictly decreasing function of xi. Okay, then draw an indifference curve. Along this axis, I am measuring xi. Okay, so along x-axis, I'm considering xi, and along y-axis, I'm considering xj. Okay, so this, if I draw the function like this, it is a strictly decreasing function in xi. If I consider a curve like this, it is a strictly decreasing function in xi. So combining all these axioms, axiom related to MRAs, axiom related to decreasing MRAs, and axiom related to smoothness of the indifference curve, we can develop a proposition like this. Indifference curve is a kind of continuous function which is strictly decreasing in xi. Okay, next I'm coming back to the idea of the curvature of the indifference curve. So last day we talked about this, just I'm making some detailing of this entire things. We did all these things. Today I'm just making detailing of the things. Okay, now I'll give you something about or discuss once again some idea about the curvature of the indifference curve. Last day also I talked about this thing. However, today I'll go for some elaboration of the slope of the curvature of the indifference curve. This thing, strict convexity axiom once again. Okay, so more on curvature of the indifference curve. More on the idea of convexity of the indifference curve. So while I am talking about diminishing marginal rate of substitution, I'm telling that it is indicating the slope of the indifference curve is becoming flatter and flatter as we are moving along the curve from left to right, and this is possible only with a strict convex indifference curve. Now, how we can present the idea of strict convexity of the indifference curve? To understand that, what we did in the last class, we considered 2 points along the indifference curve, say x and y, 2 points along the indifference curves. Okay, so it will be better if I, instead of writing x and y, if I write x1 and x2 as two commodities. So I have a two commodity world having two commodities x1 and x2. Then along I have one IC, and I'm considering a point like x and point like y. Now at x, I am consuming this amount of x1 and this amount of x2. Okay, so this is a rectangle, so this length is similar to this and this length is similar to this. So being a rectangle, we can say that we are consuming this amount of x1 while this vertical amount of x2 while I am at the point x. On the other hand, at y, I am consuming x1 and x2 by these amounts. So if I mark the points, so suppose this is K, this is L, this is M, this is N. Okay, so what I'm doing at X, I am consuming OM amount of X1. So first I'm considering the point X. The consumer is consuming OM and the amount of X2. What is the amount of X2?
Okay.
Anyone else? At Y, what is the amount of X1 and what is the amount of X2?
ON and OL.
ON, yes.
And OL.
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 Very good. So these are the amounts of X1 and X2 we are consuming at two different points X and Y. However, I am on the same indifference curve. That means both the blue and the green combinations are giving me equal level of satisfaction or the utility. Now what I am doing, I am joining the 2 points X and Y by a straight line given by XY. So I'm joining these 2 points by a straight line given by XY. This is joining the 2 points. And as I am joining the 2 points, and if I consider any point on this straight line stretch, that will give me higher level of satisfaction. In other words, the point like Z will lie on the higher indifference curve. A point like Z will lie on a higher indifference curve. It is not necessary that Z will be the middlemost point. Z can be any point along the straight line stretch XY. For any point Z lying between X and Y, or any point Z lying on the straight line stretch XY, we can show that Z is lying on a higher indifference curve. That is the combination of X and Y at Z. So let's consider the combination at Z. So if I mark the points, as say OH and say S. So at Z, the consumer is consuming at Z. What is the amount of X1 and what is the amount of X2?
OH and OS.
Okay. This combination is lying on a higher indifference curve. How we understand that? It's very difficult to draw a line in the Z board. Suppose this is IC1, so this is IC2. Are we understanding IC2 is giving higher level of satisfaction than IC1? IC2 is a higher indifference curve. Are we understanding this?
Yes, ma'am.
And are we understanding for any combination Z which will lie along the straight line stretch XY will lie on a higher indifference curve? Z can be located anywhere on the straight line stretch XY, and for any combinations of X and Y at Z, the consumer will be on a higher indifference curve. Are we understanding this? Yes,
Yes,
or
ma'am.
rest of the students understanding this?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, okay, okay. So mathematically, I can express this idea as given here. Okay. This is the idea. If I consider any arbitrary positive number lambda, when lambda lies between 0 and 1, I can write the combination of x and y as follows: 1 minus lambda x plus lambda y. This we call the weighted average of x and y. This is nothing but weighted average of x and y, where the weight is given by lambda. Lambda is the and it will have a value lying between 0 and 1. It will have a value lying between 0 and 1. Okay. Now, if I consider lambda is equal to half, then what we are getting? What is the value of 1 minus lambda then? If I consider lambda to be equal to half.
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 So what I am getting? Half x plus half y, or x plus y by 2. If I consider lambda to be half, I am getting z will indicate the average of 2 points, x plus y by 2. Are we getting this? If lambda is equal to half, Are we understanding Z will be the middlemost point on the straight line, straight
Yes, ma'am.
x?
Yes, ma'am.
Yes, ma'am.
Okay, now lambda can be 1/3, lambda can be 1/4, 1/5, 1/9. Okay, any value lying in between 0 and 1, and accordingly the position of the point Z will change. So Z is any point, to indicate any point, not the middlemost point. Okay, any point. We write the average in this format: 1 minus lambda x plus lambda y. This we call the weighted average of 2 points x and y, where lambda is any arbitrary positive number lying between 0 and 1. It is basically a positive fraction. It will lie in between 0 and 1, and this is called the required weight. Okay, so Z is the weighted average of x and y. So if I consider any weighted average of the two combinations OMOK and ONOL, and get any combination like OHOS, that combination of two commodities will give me higher level of satisfaction, because the point is lying on a higher indifference curve. Z is lying on IC2, which is to the right of IC1. So it is indicating, actually, indifference curve is a boundary line. Any point to the right will indicate higher level of satisfaction, and any point to the left, that will indicate a lower level of satisfaction. Z is lying on a higher level of indifference curve because Z is to the right of the boundary line IC1. So putting all these matters together, we are understanding any convex combination, that combination or presenting the thing as weighted average is also called the convex combination of 2 points x and y. Z is basically convex combination of 2 points x and y. Any convex combination of 2 points x and y will give the individual satisfaction which is greater than that at x. 1 minus lambda x plus lambda y is strictly greater than x. 1 minus lambda x plus lambda y is strictly greater than x. That is the satisfaction the consumer is getting at x, that is strictly lesser than the satisfaction the consumer will get if we consider any weighted average between the points between x and y. If we consider weighted average between x and y. So this is the idea. This is called the convex combination of 2 points x and y. So any convex combination will give higher level of satisfaction. Okay. So this is possible only with a convex curve. This is possible only with a convex curve. That is, if I consider the weighted average or convex combination of the 2 points, that will give me higher level of satisfaction. So this is also indicating the curve is not only convex, but also it is strictly convex to the origin. It is not only convex, it is strictly convex to the origin. Okay, so I'm moving towards strict convexity of the indifference curve. First, I started with MRS, then I talked about declining or diminishing MRS, and then I talked about convexity. Now I am talking about strict convexity of the indifference curve. Strictly a combination of x and y, a convex combination of x and y is giving higher level of satisfaction compared to the satisfaction enjoyed at point x or at point y. Okay, so this is indicating strict convexity of the indifference curve. Now, if I say a curve is a strict convex curve, what kinds of convexity I am avoiding? These 3 types of convexity, which I marked here. So now if you look at this diagram, and this diagram, while I am talking about strict convexity of the indifference curve, I am not considering this version, or this version of the convexity, because all these three versions indicate weak convexity of the indifference curve. Now, if I look at this diagram, the first diagram, what we are getting, here I have some convex part. However, in between these two smooth convex part, I have this linear segment. So the distance of the linear segment between these two parts indicating the curve is not strictly convex to the origin. It is only weak convex to the origin. Or it may happen that the curve is strictly convex here. However, it is cutting the axis. It is cutting the axis at this point and at this point. It is cutting the axis at these 2 points, which means the rest of the part of the axis are becoming the part of the indifference curve. So a convex curve, if it cuts the axis like this, that means the linear parts, these linear parts of the two axes are becoming the parts of the indifference curve. So this is also weak convex indifference curve. Finally, if I consider a straight line like this, a straight line is both weak convex and weak concave. Do you know this? A straight line is both a weak convex and weak concave curve.
Yes, ma'am.
Yes,
Yes,
sir.
yesterday.
Yes.
Yes, because if you draw a concave line like this, or if I draw a convex curve like this, okay. So this point is lying both on a convex curve and a concave curve, and in that sense, a straight line is a both weak convex and weak concave curve. Okay, so if I consider this kind of straight line indifference curve, then also we are not following the idea of or the axiom of strict convexity of the indifference curve. So while I'm talking about strict convexity of the indifference curve, I am avoiding all these three possibilities. That is, there should not be any straight line stretch in a convex curve, or the indifference curve will not cut any of the axes, or the indifference curve will not be a straight line indifference curve. So these are all exceptions. So these are not following the pattern of the conventional indifference curve. Conventional indifference curve will be strictly convex to the origin, which means if I consider the convex combinations of two bundles along an indifference curve, that will give me higher level of satisfaction compared to any point lying on the earlier indifference curve. Any question here about the idea of strict convexity?
Now, can you repeat the third point? There should not be any straight line. They should not intersect. And what is the another point?
We should not consider an indifference curve which will have a straight line stretch, or which will not cut any of the axes, or which will not be a straight line. These three possibilities we have to avoid if I consider a conventional indifference curve. A conventional indifference curve will be strictly convex to the origin. And the meaning of strict convexity is if I consider any 2 points along the indifference curve and consider a convex combination of two commodities, the convex combination will give the consumer higher level of satisfaction. if anyone has any question. So hope this is clear to all of you.
Yes, ma'am.
Okay, so now I'm coming to this point. Though we are considering conventional indifference curve will be strictly convex to the origin. However, when we come to the reality, it is possible that indifference curve has different shapes. It is possible that indifference curve is not always negatively, not always strictly convex to the origin. Okay, so now I am introducing several exceptions when the indifference curve will not be a strict convex curve. So, however, it must be admitted that there are pairs of commodities for which the indifference curve may not be a smooth convex curve. The first case, if a consumer is totally indifferent between two commodities, that is, if the commodities are perfect substitutes, the indifference curve becomes a negatively sloped straight line. So, so here I am considering a case where the two commodities are perfect substitutes. Earlier, when we introduced the nature of the commodity, etc., we talked about substitutes like tea and coffee, etc. So here I'm talking about that kind of commodities. The two commodities are perfect substitutes to each other. So if in reality, if we find that commodities are perfect substitute to each other, in that case, let's see what is happening. So this is the indifference curve I am considering. Now I can consider these combinations of x1 and x2, okay, or I can consider this last point where the consumer is consuming only x1 and still remaining on the same indifference curve, or I can consider consumption of only x2 still the consumer is on the same indifference curve. Okay, so here I'm considering different points, you know. So say I'm considering a two commodity world first of all. So I'm considering this point A, this point B, this point C, and this point D. All A, B, C, D are lying on the same indifference curve. All A, B, C, D are lying on the same indifference curve. That means consumer is equally satisfied at all the points A, B, C, D. Now, peculiarly, when I'm considering a point like A, consumer is consuming only X2. Okay. When I'm considering a point like D, the consumer is consuming only X1. Okay. For B and C and for any points lying in between A and D, consumer is consuming some amount of X1 and some amount of X2. However, because of perfect substitutability between the commodities, you know, here the slope of the indifference curve is a constant one. MRS is a constant. Along a straight line, I see. So I'm not getting MRS is declining as we are moving from left to right along the curve. As I'm moving from left to right, A to B, B to C, and C to D, MRS remains fixed. MRS is a constant. MRS remains fixed. Okay. And for that matter, I can perfectly substitute one commodity by the other. So that is, I can be at points like A and D. At point A, I am consuming no amount of X1. At point D, I am consuming no amount of X2. Still, I am lying on the same indifference curve. This is possible only when the commodities are perfectly substitute to each other. Okay, so this is a possibility. If the commodities are perfect substitute to each other, then what we will get, the IC becomes a negatively sloped straight line. So it is presented by a line like this, UXY is equal to AX plus BY. It is presented by a curve like this. Okay. So in case of substitutes, what we are finding that MRS remains fixed. This indicates the indifference curve will be a negatively sloped straight line, and this indicates the indifference curve can cut both the axes. This indicates the consumer can consume only one commodity and will still remain on a same indifference curve. Is it understandable?
Yes, ma'am.
Others?
Yes,
Getting
ma'am.
Yes,
when
ma'am.
the commodities are perfectly substitutes, the indifference curve will become weak convex. It will become a straight line. Clear to all of you?
Yes, ma'am.
Yes, ma'am.
Kartika, Shuparna, Madhura, getting the things?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Next, we are going to the another case, B. If two commodities are consumed in fixed proportions, that is, commodities are complementary to each other, then IC becomes L-shaped. Okay, so what I am telling, I'm now talking about the complementary commodities. Complementary commodities like bread and butter, milk and sugar, tea and milk, hard drive, hardware and software, pen and ink, this kind of combination. The commodities are consumed together. Now, while I am using a pen, a particular proportion of ink will be relevant to me because there is a proportion, you know. So with a single pen, if I have 1,000 number of refills, 999 number of refills will become redundant to me, because for a single pen I can use only one refill. Okay, so 999 number of refill will remain unused. Now, if I use 1 spoon of sugar with 1 cup of coffee, in that case, more sugar in sugar bowl remains redundant to me, because I use the thing in a proportion. 1 cup, 1 cup of coffee I consume with a teaspoon of sugar. This is the combination. For a particular hardware, there is a limitation that this much software I can use, given this version, given everything same. For this typical hardware, I can use this typical software. Okay, for for 2 slices of bread, I can use a particular amount of butter. More butter will be redundant to me. So this is the idea. The commodities are consumed in a particular proportion. If this happens, in that case, the indifference curve becomes L-shaped. Okay, so let's see what is happening here. I do use a new. Okay, so this is the thing. So this is the L-shaped indifference curve. Now I can draw a straight line like this. This green line passing through origin is indicating the proportion at which the two commodities X1 and X2 will be consumed. This is indicating the proportion at which the two commodities X1 and X2 will be consumed. Okay, so let's mark the points first. Two commodity world, X1 and X2 being two commodities. Okay, this is IC1. This is say point A, and this is say OK. So OK, the ray OK passing through the straight line, or the ray OK passing through the origin, indicates at which the two commodities X1 and X2 will be consumed. Okay. So now suppose I am thinking about a point like B. I'm thinking about a point like B. So at point B, I have same amount of X2, however, more of X1. Okay. So you can add, if I compare the 2 points A and B, B has more amount of X1 and equal amount of x2 with respect to A, with respect to the point A. So if it is a standard case, definitely B is preferred to A, isn't it? B is preferred to A because B has one commodity more. Am I right? If it is a standard case, B should be preferred to A.
Yes, ma'am.
Yes, ma'am.
And B should lie on a higher indifference curve. Isn't it? Because along an indifference curve, I need BIA. B should be indifferent with A. So if I follow the conventional pattern, B consists of more x1 given the other commodity similar, identical. So B should be preferred to A, and for that matter, B should lie on a higher indifference curve. Am I right? If it is a standard case?
Yes, ma'am.
Yes.
However, here that is not happening. Both A and B are lying on a same indifference curve. In this particular case, though B consists of more of other commodity x1 and same amount of x2, we are finding that B lies on the same indifference curve. Why? Because given this amount of x2, given this particular amount of x2, this AB amount of additional x1 remains redundant to the consumer. So if I mark the point, given OL amount of x2, the additional AB in other words, given the fixed amount of x2 OL, the AB amount of x1 becomes redundant to the consumer. It becomes redundant to the consumer. It has no use to the consumer. More sugar in a sugar bowl has no use. More refill, if my number of pen is 1 or 2, is of no use. Okay. More sophisticated software has no use if I have a type of hardware which will be not able to match with that kind of sophisticated software. So the things will be consumed together. Okay, the commodities are complementary to each other, which means the commodities will be consumed following a particular proportion given by the ray OK. Given by the ray OK. So more amount of the other commodities given the other commodity fixed will have no additional use to the consumer. Similar thing will happen along the vertical stretch as well. Along the vertical stretch as well. Okay. Just a Given this particular amount of x1, if I consider a point like this additional amount of the commodity has no use. Given AL amount of x1, if I consider this point as say D, AD amount of x2 becomes redundant to the consumer. Okay, so this is happening. So in other words, consumption takes place only at the kings. Here, point A. Only at the kings, where the lines are basically cutting each other, crossing each other. At point A, the two red lines are cutting each other. So this is a point of king. And if I consider more indifference curve, it will be like this only. Consumption will take place only along the line OAK. So this will be the relevant thing, okay? Any point beyond these kings remain redundant to the consumer. Consumption will take place only at the kings, okay? That is points like this or this, only at the kings consumption will take place. Now this kind of indifference curve can be presented using this equation. U of xy is minimum of ax comma by. Whichever the minimum at that point, the consumption will take place. Okay, minimum of ax by. In the earlier case, it was ax plus by. And here it will be determined by the minimum of 2. Whichever is minimum, consumption will take place at that point, because consumption will be taken together. Consumption will be done together, executed together. I want a fixed amount of both commodities. I can consume only a fixed proportion of both commodities. Extra commodities will become redundant to me. So this kind of equation can be presented by a line like U of xy is equal to minimum of ax plus by. Any question regarding the complementary consumption and having L shape of the indifference curve? This is also called the rectangular indifference curve. So it is L-shaped or rectangular indifference curve. Any question? Any part? If I need to repeat.
Ma'am, as the indifference curve is L-shaped, if we consider the vertical part, ma'am, then on two subsequent points, like the right hand side, any point on the right hand side is certainly more preferable than the on the left hand side, na? Then, ma'am, actually this part I was a bit confused actually.
Yes, you know, this IC is definitely higher than this, no doubt. However, given a fixed amount, all these points are redundant to the consumer. Yes, it is true, along the ray, if I consider higher point compared to A, that will lie on the higher indifference curve. Okay, so this IC, say IC2, that is definitely indicating higher indifference curve. And consumer will have more satisfaction if I can change the proportion, you know, at this point compared to this point. Okay, so just more.
Yes, ma'am. another thing, which I was actually asking, just see about the 2 points A and B. Like B is certainly having a higher amount of providing a higher amount of satisfaction, no? Because
Yes.
the x1 is greater while the x2 is constant. So, but it is an indifference curve. Then, ma'am, it should have provided the same amount of satisfaction, no?
These are the special cases, as I mentioned. This is not a conventional IC, isn't it? Here, this amount is redundant. Though I have more of X1, this X1 is redundant to me. What I'll do with more butter if I don't have adequate bread?
Oh, okay, ma'am. I can understand.
Okay?
Like
So
it works for the complementary goods mainly. Then.
yeah. So, however, it's not that all the points, I have no point by which I'll be able to go to the higher indifference curve. It is not the situation. Here, I can go to a higher indifference curve if I change the proportion of both the commodities. Okay. So, if
Okay,
I
ma'am.
come to this point, actually, I am changing the proportion of both x1 and x2. Okay, so
Yes, ma'am.
this point definitely, or any point along this indifference curve, IC2, is definitely giving me the higher level of satisfaction because I could change the combination of both x1 and x2. Okay, so if I can
Yes,
change
ma'am.
the proportion, definitely I'll move to a higher indifference curve. However, I need to maintain the proportion because I
Okay, ma'am.
consume the commodities in a fixed proportion. That is the idea of the complementary goods.
Yes, ma'am. I can understand now. Thank you, ma'am.
Okay, anyone else? Any other question?
Yes, ma'am, I had a doubt. Ma'am,
Yes,
if on the curve IC2, suppose there is another point D which is not located at the kink,
yes.
then would we prefer A or would we prefer D?
No, there is no question of preferring. I'm just marking first. You are talking about a point like this. Say this. Okay, am I right? Now you
Yes, ma'am.
think whether this brown point will be preferred to A,
Yes, ma'am.
right? No, this brown point will be not preferred to A because it is not lying on the ray OK. It is
Ma'am,
not,
even if it is located on a higher indifference curve.
it is on a higher indifference curve, that is true. However, it is not a point where the consumption will take place. Okay, so
Yes, ma'am.
here the equation is minimum of ax by. So here, I'm considering any other point apart from the kink. This point is irrelevant to the consumer. The brown point remains irrelevant to the consumer, whatever be the amount of x1 and x2 it consists of, because it is not following the proportion at which the two commodities can be consumed. So consumption will take place only at the kinks. Consumption will
Uh,
take only along the ray OK. Yes,
then,
please.
ma'am, why don't we like directly make OK the indifference curve here and not these
OK is
L-shaped?
not the indifference curve at all. OK is the locus of points of consumption. It is taking care of the entire indifference map. So I can draw a number of indifference curve in this commodity space, and OK is connecting all the relevant points of consumption. So it is not the indifference curve. It's not that along OK, I am indifferent in all the points. So if I compare a point like, say, just, this point, say, K, say, or H, say. Suppose this is H. H is giving me higher level of satisfaction compared to A. So H is preferred to A, not HIA.
Yes, ma'am. Okay.
Okay?
Yes, ma'am.
OK is not at all an indifference curve. It is connecting only the points of consumption. So consumption will follow this proportion. OK is indicating the proportion at which the two commodities will be consumed. Okay, so it cannot be the indifference curve because along OK, the points are either preferred to, not preferred to. I think you got the point.
Yes, ma'am.
Any other question? For the rectangular indifference curve, any other question? So this is presenting the consumption of the complementary goods. So in reality, sometimes the indifference curve will be like this, and it will be presented by the equation u of xy is equal to minimum of ax comma by. So finally, coming to the properties of indifference curve, later we will introduce more varieties of the indifference curve. Okay, once we learn about consumers equilibrium, we will introduce more varieties of the indifference curve. Indifference curve sometimes may be concave to the origin as well. Here, since you have idea about the substitutes and the complementary goods in this context, just I introduced the idea of the indifference curve if the two commodities are perfectly substitutes to each other, and the idea of the indifference curve when the two commodities are complementary to each other. However, the indifference curve can be like a wave. Indifference curve can be concave to the origin. So it will be, all these things are nothing but the special cases. Okay, these are not the conventional cases. These are the exceptions. So in a particular context, the IC may be circular, IC may be concave, IC may be straight line, IC may be of L shape. So there may be different shapes. So finally, coming to the properties of the indifference curve, we are finding that axiom of continuity is stating ICs come from northwest to southeast, hence negatively sloped. And then we elaborated the slope can be captured by marginal rate of substitution. What is marginal rate of substitution? How we can derive the slope of the indifference curve. So we elaborated these points. The second property is axiom of non-saturation, providing higher indifference curves implies higher level of satisfaction. Higher indifference curve implies higher level of satisfaction. Now, what is the axiom of non-saturation? Axiom of non-saturation is more is better. More is better. Then convexity axiom gives ICs are strictly convex to the origin. ICs are strictly convex to the origin. Now I am coming to the fourth property, which we didn't discuss so far. In an indifference map, while ICs need not to be parallel, they cannot intersect each other. I'm telling about an indifference map now. I'm talking about the entire commodity space, and I'm telling that in a commodity space, I can consider more than one indifference curves. In other words, I can consider infinite number of indifference curves, or I can consider indifference map. In a two commodity world, in a commodity space, I can consider the entire indifference map consisting of thousands and thousands of indifference curves. I'm telling that while it is not necessary that two indifference curves will be parallel to each other, however, they cannot intersect each other. They cannot intersect each other. So let's try to understand the point. Okay. So ICs may be like this. These are the set of indifference curves where the curves are not parallel to each other. Okay, in one case, as the two lines are moving towards the x-axis, the curves are becoming close to each other. In case of IC3 and IC2, we are finding that as we are moving towards the y-axis, the curves are coming close to each other. So if I consider this is IC1, this is IC2, this is IC3, okay. If I consider a two commodity world, commodities being X1 and X2, we are getting this thing. A set of non-intersecting lines. So we don't need that ICs will be parallel to each other. They may be non-parallel to each other. However, they should be non-intersecting. The two indifference curves cannot intersect each other. So we have to logically establish why two indifference curves cannot intersect each other. So let's try to understand that. So again, a two commodity world. This is IC1 and this is, say, IC2. Keep the two curves strictly convex, don't merge the line with axis. So keep it like this. So I'm to prove these, the two indifference curves cannot intersect each other. I'm starting with two intersecting indifference curves, IC1 and IC2. And then I'm considering two points PQ first, then okay, I'm considering 4 points, P and Q, R and S. So this point is P, this point is Q, this point is R, and this point is S. Okay. Now, if I compare P with Q, P and Q consist of same amount of X1. However, P consists of more amount of X2. Am I right? Please look at the diagram and tell me whether I'm right or not. I'm telling between the points P and Q. P consists of more of x1, more of x2 compared to q. However, both consists of equal amount of x1. Am I right?
Yes, ma'am.
Yes.
Yes, ma'am.
Everybody is getting that? P has higher amount of x2
Yes, ma'am.
and same amount of x1. Same amount of x1 আছে তো? Yes or no?
Ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, so can I write? Can I write this?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now if I compare Q and R, Q and R lie on the same IC. Both Q and R lie on IC1. Am I right?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So what will be the relation between Q and R?
QIR.
Ma'am, P is preferred to R.
No. If the 2 points lie on the same indifference curve, one will be indifferent with other, isn't it?
Yes, ma'am.
Somebody
Yes, ma'am.
prefer to, that is the wrong answer. Q is indifferent with R because Q and R lie on the same indifference curve. So QIR. Okay. Now if I compare between R and S, okay, are we getting R is preferred to S? Everybody?
Yes, ma'am.
Okay, so what I'm finding, P is preferred to Q, Q is indifferent with R is preferred to S. So transitivity will give us P is preferred to S. Are we getting this? So first applying the principle of non-saturation, we are finding P is preferred to Q. Following the property of indifference curve, we are finding QIR. Again, non-saturation tells us RPS. And then applying transitivity, are we getting P is preferred to S? From these three?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
However, P cannot be preferred to S because both of them are lying on the same indifference curve IC2.
Yes, ma'am. It's contradicting.
Yes, contradictory. However, this is not possible as P and S lie on the same IC. Okay, so if the two indifference curves are intersecting each other, then we are getting a contradiction. If two indifference curves cut each other, two indifference curves intersect each other, we get a contradiction. Hence, the two indifference curves cannot intersect each other. The two indifference curves should be non-intersecting. It's not necessary that they will be parallel. However, they should be non-intersecting. Any question? Everybody got it?
Yes,
Okay,
ma'am.
same idea here. So first I can consider one point is preferred to R, then second is indifferent, third is preferred to, and then applying transitivity, we are reaching at impossibility. Okay, the thing we already did. Do anyone have any question? Next, two utility functions ux and say u star x. Two utility function. I am considering two utility functions, u, which is a function of x, and u star, which is also a function of x, represent the same preference ordering if and only if the real numbers u and u star are related as shown in the following figure. So this is the diagram. U and U star. The two functions U and U star, both are functions of X. Okay. So if they are related in this way, one is an increasing function of X, they are indicating similar kind of utility. They are indicating similar kind of utility. In the diagram, U star is everywhere an increasing function of U and vice versa. Vice versa means U is everywhere an increasing function of U star. This relationship among utility functions that represent the same preference ordering and generate the same indifference classes, that is, utility is unique only up to an increasing or monotonically increasing transformation. This relationship among the utility functions that represent the same preference ordering and generate the same indifference classes indicates monotonically increasing transformation of one another. Okay, so we have to understand this idea. Now I can consider three forms of the utility function. U is equal to U of x1, x2 plus a constant. Or I can consider U is equal to a quadratic function, U square of x1, x2. Or I can consider U a logarithmic transformation of the utility function U of x1, x2. The three functional forms I have written, where the basis is U as a function of x1, x2, are monotonically increasing functions of each other. That is, all of them are indicating similar kind of ordering of preferences. The mathematical functions are different. In one case, I'm linearizing the function when I'm considering logarithmic transformation of the function. Okay. In other case, I'm considering a quadratic. In the first case, I'm directly considering U as a function of xy plus a constant, say. So if I consider this kind of transformation of the utility functions, they are basically same, indicating the same indifference map in the commodity space. All the equations are indicating similar type of indifference map, same ordering between the two commodities x1 and x2. So here we need to understand the idea very well. Now, when I am talking about the indifference curve, this entire idea is based on ordinal approach. Developed by Higgs. So what we are assuming that given different bundles of commodities, consumer will be not able to say how much utility or the satisfaction they are getting out of this. However, they will be able to rank their preferences. So different combinations of two commodities are given to the consumer. Okay. Say X11, X21. This is one combination of two commodities. Then the second combination is given by this. Third combination is given by this. Same commodities I am considering, however, different combinations of commodities I am considering. So given these combinations of commodities, consumer will be not able to say how much utility I am getting out of this. That is, I'll be not able to say the value of this. I'll be not able to say this. However, given these three combinations, I'll be able to compare them. I'll be able, if I call this A, if I call this B, or if I call this C, then I'll be able to say whether A is preferred to B or not, or B is preferred to A or not, whether A is preferred to C or not, or whether B is preferred to C or not. So this kind of ranking I'll be able to give. Whether one bundle is indifferent with other, whether one bundle is preferred to other. So this kind of ordering I'll be able to indicate. However, I'll be not able to say how much satisfaction I'm getting out of this bundle. Now, when the consumer theory, the entire idea started to form, there were two parallel economists. One is Marshall and another is Higgs. Marshall thought in this way, there should be a unit of measurement using which I'll be able to say this much satisfaction I am getting out of this combination of commodities. Whereas Higgs started to tell it is difficult to measure the utility or the satisfaction which are abstract in nature using some unit of measurements. He tried to say that given the baskets or different combinations of the commodities, consumer will be able to identify which will satisfy him or her much compared to the other. So it is not possible to say this much satisfaction I am getting out of this. However, I'll be able to mark this is better to me, this is worse, this is equivalent. So I'll be able to order my preferences. So this entire concept is known as ordinal approach. In Higgsian theory, therefore, there is no unit of measurement to indicate the volume of satisfaction. So, we can use, anything to indicate the order. So, you can say that it can be considered by, say, numbers 1, 2, 3 like this. If I find that A is preferred to B, B is preferred to C, in that case, I can say that A will lie on a first indifference curve IC1, B will lie on the second indifference curve, which is lower than the indifference curve on which A is lying. And again, we can say that C will lie on an indifference curve, you know, below the curve consisting of B. So we can say about this, if A is preferred to B and B is preferred to C, in that case, A will lie on this indifference curve, whereas B will lie and C will lie, sorry, I see 3. So this we are understanding. This we are understanding. Okay. So, you know, I can consider a function u of xy plus c to present this set of indifference curves, or I can use if I consider the first function as, I can consider any transformation, or I can consider function of function of function like this as well. That is, I can consider like this. So g of h of f of xy, this is nothing but function of function of function of same two commodities x and y. So g of h of f of xy is nothing but monotonic transformation of u of xy. H of f of xy is another monotonic transformation of f of xy, whereas g of h of f of xy is another transformation of f of xy. However, if we solve the exercises, we will be able to show the same amount of two commodities will be optimum to the consumer. The same amount of, if the utility functions are monotonic transformation of each other, ultimately at the end of the day, we will get the same amount of optimum x and y out of all the functions, which will maximize consumer satisfaction subject to the income constraint. So if I try to find out the consumer's equilibrium or the optimum satisfaction subject to the income constraint using any of the functions, we are reaching at the same amount of two commodities. If this happens, in that case, the original utility functions are nothing but monotonic transformation of each other. We are presenting the order by different names. Sometimes I can present it by ABCD, sometimes I can present it by 1, 2, 3, 4. Sometimes I can present is u log of y, log of u, log of u. So in this way. So they are indicating the same ordering of preferences. The functions are basically the monotonic transformation to each other. ABCD are indicating similar order to that of 1, 2, 3, 4. Or I can consider 100, 101, 102, and 103. I can consider the ranking in 3-digit scale, or I can consider the ranking in 5-digit scale. However, they are indicating same kind of ordering. Okay, so that's the idea. So if I can call you by your name, I can call you by your class roll number, I can call you by your registration number. So whatever be the thing, one is the monotonic transformation of the other. It is indicating to the same ordering. It is indicating the same bunch of individuals. That's all. These are the different names of the same thing. Okay? Thus, no unique utility function exists for the individual. Any order-preserving function will suffice. In other words, the utility index is ordinal. So this is a very important note. So you have to keep in your mind, many a times utility function will be monotonic transformation of the other. If it happens, actually both the functions are indicating the same set of indifference map. Any question? Perfectly understandable? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. So,
Ma'am, please show that page.
this one?
Yes, ma'am. Just for 2 minutes.
Yeah. Now I'll give a break for 5 minutes and then I'll start once again. Is it okay?
Yes, ma'am.
Okay, so let me stop at this point.